Hello. Good evening, Dr. Ajith.
Good evening, sir. How are you?
Fine, fine.
Very good, very good.
Can you see me?
Yeah, your video is not there. Video. Sir, you switch on your video.
I have switched on. I don't know what happened.
Not come. It does not come. Just try once more. Yeah, very good. Welcome. Very good. So, Deepthi, you are there, Deepthi?
Yes, sir, I'm there.
All have come. Our George sir has come.
Yes, sir, George sir has joined.
So that
Participants are still joining.
Very good. Let them join. We'll wait for a few minutes. Let them join. Okay.
Sir. Okay, sir.
My company, there's a guest, a senior guest. Okay. His name is Dr. Pine. He's a mechanical engineer by profession. Okay.
Okay, sir. Hello, sir.
Hello.
He's Fine, sir. Nice of you to come and join us.
Yeah, pleasure.
So did you join yesterday?
No. Actually, I have a few lectures on Friday, Saturday.
Oh.
So I'm preparing PowerPoints. So I thought I join 1 hour
Okay.
here.
Very good, very good, very good. So we'll just wait for a few minutes, We'll start. Okay. Deepthi?
Yes, sir.
Deepthi, did we cover e-governance yesterday? We didn't cover e-governance, no, yesterday?
No, sir.
We'll cover it today, okay? There are some more things to there.
Okay, sir.
Sure. Just a few minutes. I'm just preparing some questions. Just a few minutes.
Sure, sir.
Yeah, sure. Hello? 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 Yes? No, you please call later. I'm busy now. George sir has come, Deepthi?
Yes, sir. George sir is in.
Just a minute. Just I'll take 2 more minutes. And Neetu ma'am?
Neetu ma'am, I think she's not there.
She's here. She is here.
Okay, she's here.
Thanks, sir. Good evening.
Good evening, ma'am.
Hi, Deepthi. Hi, Vaishnavi.
Hi, ma'am.
Hi,
Hello,
ma'am.
sir. Fine, sir. Hello.
And thank you. Thank you for joining. Just start. Just 1 minute, that's all.
Yes, sir.
Good evening.
I was waiting for it. Just taking 1 minute.
Yeah, I was here only.
Very good, sir. So nice, all of us are here together.
We can start, no?
Yeah, just
Then people will join gradually.
Okay, sir.
yeah, sure. Just a minute. Okay. So, Deepthi, shall we start? Vaishnavi?
Yes, sir. Sure, sir.
Yes, sure.
Very good, very good. Okay,
Uh,
sure.
Sir, I'll give a small introduction.
Yeah, sure.
Good evening to one and all. Hope you all had a very good day. So today we are here for the day 2 of the talk session on Smart City by Dr. Ajith Chandran MC, and hope you all enjoyed yesterday's session. Today we have a special guest, Dr. Pine, a colleague of Dr. Ajith Chandran sir, and we also have Dr. T.M. George sir, Director of MARBCLS Corporate Relations, and we also have faculties Neetu Roy ma'am and Jijo Jo sir. I welcome you all to today's session. Over to you, sir.
Thank you for a wonderful introduction as usual. So I mean, today we have a strength of around 60. I hope it will go and cross 100. So today what we are going to talk is about IT and communications. As discussed yesterday, we'll be a little, tending towards electronics and communication, ECE, instrumentation, and computer science. But we'll have some very good stuff for other engineering disciplines also. Okay, so to start with, let us just recap what was done last time. I just run a quick poll to see how it was last time, and there are two things which we discussed, not exactly covered, but I hope you'll be able to answer. I'm just launching a small poll on something that is going to come up today only, but just to know how much you are aware of this. Okay, there it goes. Please answer them. Please answer them in half a minute or 1 minute. Huh? Okay, with 30% done. Let us make it fast. Okay. It's 40% now. Please come forward. It is anonymous. We are only looking at the number of correct answers. Okay. It was covered a little bit yesterday. Covered today also. Okay, I'll end it now. And I'm going to share the results. Okay, so 83% has answered correctly. This Intelligent Traffic Management System, ITMS. And the bus rapid transport system is also absolutely right. So I'm so happy to get the majority of participants answering correctly. Good. Now, let me ask you one more. Okay, one or two more, and then quickly jump into the topics. It's just for. Okay, now this is over. This is over. Now let me take another one. Let's see how you answer this. You are able to, Deepthi, we are seeing now. Everybody, Vaishnavi?
Yes, sir. Yes, sir.
Please.
It's visible.
It's a simple question. Deepthi, 2 people have entered. 3 or 4 have entered.
Yes, sir. I have admitted them.
Okay, we have crossed 50%. I'm stopping and seeing the results. I'm sharing the results with you. Results are visible now. Deepthi,
Yes,
results
sir.
are visible.
Yes, sir. We can.
Yes, sir, it
It's
is visible.
The majority, 77% has answered correctly. I'm feeling happy. Okay. Okay, now closing this, I'll take another one more. Now let me go to next one. Yeah, what is this right or wrong? Just tell me fast. Okay, let us share the results. We have got crossed 50%. Yeah, it is again right. Now one last question. One last question. Just a minute. Please give a go at this. Okay, good. Let me share the results. So all the questions have been answered correctly. This also is right. I'm feeling good. Okay. Now let us get on with the business. of discussing about the smart city. We'll start where we left yesterday, and I have some other additional information for you based on the feedback of yesterday. Okay. So let me start the presentation, which has compiled for you. Okay. Started and visible now?
Yes, sir.
Am I loud and clear, Deepthi?
Yes, sir. You're audible.
Very good, very good, very good. So let's start. Now, today, we will deal with, let me adjust the screen. Huh? Okay. So today we'll deal with, for yesterday we dealt with, what did we deal with yesterday? Let's have a look. Okay. We dealt with the concept, smart city concepts, the evolution, the challenges, then showed you the data center, how it works, how it looks like, how it works, what are the functions of that. And then the topology of smart cities, we covered the smart energy part and the smart buildings part. And a chunk of it is left for today. We'll see how much we can do justice to this. So here, depending on the feedback yesterday, I have enriched the content to include, the role of engineers in smart cities. After that, we'll go on. We'll continue with the topology. We'll discuss the smart IT and communication. This will be a special interest to ECE engineers, and to a good extent to computer science and electrical as well. Others also. It is see, nowadays it's a era of a hybrid discipline. No, that is, engineering is not complete unless you know a little bit of everything. Okay, so even in S1 also nowadays, and under KTU, all the major disciplines are covered. So going with that, even others also would find it interesting and find it knowledgeable. I'm pretty sure about that. Okay, now we'll follow it up with smart environment, then smart e-governance, then smart transportation, with illustrations from Holland, UK, and India. If there is any spillover, we'll take it up on Saturday. That's not a problem. Okay, now let us go to the role of engineers. Okay, the role of engineers. The civil engineers have good things to do here in the smart cities. What will they do? They can be hired for embracing the latest technologies and data for urban infrastructure. For developing urban infrastructure, the civil engineers role, the bright civil engineers of India will be called for to work for the 100 smart cities. And which are the 100 smart cities we discussed yesterday? It was in 4 rounds. And our city, Trivandrum, is also one among them. And now it stands at number 46 among progress, among the, as regards the progress made. And then the civil engineers can play a role in improving the road infrastructure. Widening of roads is very important for a smart city. Then green building. What is a green building? We discussed in the building aspect of smart cities. I showed you beautiful examples of smart bricks, smart concrete, smart pavement, etc., where sensors are built into the walls to study the stress and report through the IoT network for any misbehavior or any abnormal situation, which can be stitched in time so that major calamity can be avoided. I also explained to you about smart windows, where the window shade increases in its opacity as per the entry of light. Okay, so these are the areas where the civil engineers can play a role. Yesterday, there was a lot of inquiry regarding internships. I'll definitely help you through your corporate director, George sir. Okay, through that department or through that vertical, we can connect and find out internships for whoever is interested. Okay, we'll discuss it as our relationship continues. Okay, now.
Okay, sir.
Sure, thank you, Deepthi. Any questions, please ask, because I like it to be interactive, because this is not a lecture session, it's not a monologue that I keep talking and you keep listening. You can ask in between. I'll answer to the best of my ability and dexterity. There may be some things which I may not know, but then nobody knows everything. We are all learning. All of us are learning things, new things daily. Civil engineers also will be asked to do advanced water management system for effective use of water, because in nowadays it's not just simple supply of water. There are various sensors used to measure pressure. And we have variable frequency drives for motors, the major pump motors, which the drive of the motor torque is proportional to the pressure in the main pipeline. So the pressure is sensed using various instrumentation sensors, and the pressure of the pump through feeding a voltage, it is increased, and the pressure means frequency, the drive is increased to pump in more water. That smart waste management system, I'll show you a pictorial example of that, so that I won't explain now. Then they are called to do institutional and social infrastructure building for promoting smart societies. There are various examples of this. One of them, or a few of them, I showed yesterday as parks in our city coming up as a part of the smart city project. But I showed you one park under the Kerala Water Authority coming up in Vellayambalam. Okay, there's a beautiful park coming up. So already there, it's to be made smart. So in such areas, the civil engineers have a lot of things to do. Okay. Then what about the computer science and electronics and communication engineers? They have to work hand in hand to embrace latest technologies in ICT. What is ICT? Information and communication technology. Okay. Vaishnavi and Deepthi, I hope both of you look at the chats, because if I look at them, I may be deviating. Okay.
Okay, sir.
Okay. Sure. Then, of course, the IoT, Internet of Things. I think there is the same bread has to be shared by computer science and electronics engineers. Electronics engineers to work on the embedded area, the embedded domain, and the computer science engineers to work on the cloud domain. And the interaction and the combined effort of them result in an IoT stack. Okay. Now for e-payment, more computer science engineers are to be involved in e-payment, because as you study later, as you will be told later, the smart cities have smart governance. So we can do everything sitting at home. You can have to move, even land tax can be paid using the e-payment system. The development of that will call for the services of computer science and IT engineers. Then what about instrumentation automation? Either instrumentation engineers or electronics engineers, they will be required for calibration, installation, and testing of various sensors like piezoelectric sensors, PIS sensors, then proximity sensors, and then even temperature sensors like thermocouples, RTDs, etc., thermistors, and so many such types of sensors. Then we will also need humidity sensors, hygrometers, of course, pressure transmitters, etc. The maintenance, calibration, installation will call for major employment for electronics engineers and instrumentation engineers. Then to create a digital platform for smart transportation, both electronics and computer science engineers are required. Then data analytics. What is this data analytics? The data collected through IoT stack. I'll explain what IoT and all is about as we progress. The data collected in the IoT stack has to be analyzed. So data is the oil of the new era. So unless this data is analyzed into wisdom, it cannot be put to good use. So it's a kind of feedback control using data as the feedback element. So if you get proper data, it can be utilized for improving things. Then automotive electronics for promoting fuel efficient cars. Autonomous driving also is coming up. Automatic driving is already there. Autonomous driving means driverless driving. That also is coming up in smart cities. So for all that, a lot of work is required in automotive electronics.
Hello.
Somebody has to be. Deepthi, can you?
Hello.
Is it Hari Krishna who is talking? I think
I request all the participants to please mute your mic so that there is no interference in between.
Thank you, Deepthi. Thanks for their support. Now proceeding, so summarizing the computer science and electronics engineers roles, is basically to build a digital platform for transportation, that is vehicle tracking system, then fleet management systems, then smart parking, and then smart buildings. Everywhere these two domains of engineers have to work together, and also in automotive electronics. Then they have to work hand in hand in instrumentation, then communication systems, etc. Now, mechanical engineers, they have a big role to play in providing the infrastructure on which the electronics engineers and computer science engineers can work, and the electrical engineers can work. That they have to play their role in developing is fuel efficient vehicles. So fuel is at short supply. Alternate fuels have to be developed. Harnessing of non-conventional energy sources have to be done for different machinery, for industry automation, for medical equipment automation, and to make public transport faster by various methods in the drive mechanisms, etc. Then harnessing non-conventional sources, industry automation. Then I think there is a mixture. I just didn't get time to make public transport faster and efficient. Then we come to the IT part. This, participants, is the most important part of smart cities, smart IT and communication. This forms the backbone of the smart city framework. How it happens? Let us have a look at it together. Okay. So any doubts on what the engineers could do in smart cities? I've only given a nutshell. There are some, can you tell me what all, any doubts? No, Deepti, nothing, no?
No,
No,
sir.
sir. You can proceed.
Okay, we'll
sir.
proceed to the vision of smart cities. You see? Yes, yeah, we'll proceed. Thank you. So the vision of the future smart city paradigm is based on what? On the connectivity part. So we should have an interoperable access and interconnection among various dissimilar objects. Let us see how it happens. Okay. To provide the delivery, services delivery, and the right information through various devices working on different technologies like sensor networks, machine-to-machine communication, network virtualization, etc. A proper communication framework is necessary to take all these things in hand. And anybody who knows about network virtualization, the computer science and electronics engineering students, I mean, can anybody have a go at the question? What is network virtualization?
Participants, please feel free to interact with, sir.
Sure. Thank you. Okay. So that is actually a concept of network connectivity using less and less hardware and more of cloud-based systems, so that transportability and mobility increases. I was mentioning about this a little bit yesterday. So network virtualization means all the hardware gadgets will be replaced by virtual software parameters without affecting the efficiency. How it goes around, we'll see soon. And what is this machine-to-machine communication? Say machine-to-machine communication is simply the data transfer between various machines as a part of the IoT network. How it works and all, we'll see sooner. Just have some patience. Okay. Then you must be familiar with this network. This is what was happening till yesterday, till 2005, 2004, like that. This is a conventional network, a communication network, having wired connection as well as wireless connection. So what do we see here? The web content also gets streamed to mobile devices. These are the various devices you see, which are connected via mobile data communication and other means of communication to the internet. And the web content and various enterprise and personal data gets transferred on a bidirectional basis to the various devices like fax machines, data machines, PCs, palm tops, desktops, laptops, digital meters like multimeters, etc. Now, what changes now is what we'll see just now. Okay. IoT has brought a sea change to this network. Now, not only computers and computer-enabled devices, but simple machines also connects to the network. Okay, that they also connect to the network. It is a key to what? Smart city, IoT concept. The key technology behind the success of smart city initiatives are the following, and they are all dependent on IoT. Pollution levels to be improved, sensors are required, and IoT stack is required. Traffic management. Traffic management is not what we see in the streets of Trivandrum and other places, like just giving a timer, 2 minutes one way, 3 minutes other way, like that. And this adaptive traffic management system, or it's called intelligent traffic management system, we'll have a go at it also. Environment, that is, improving the environment or protecting the environment by using various wireless sensor networks. I have a case study on that also. Parking, smart parking. That is, you never know. Use LoRa. How many of you are familiar with LoRa? Any answers? Any responses? Are you familiar with LoRa?
Yes, participants, please feel free to type your answers in the chat box.
Yeah, they're typing. Yeah, typing or I don't know. Okay.
No, sir.
Okay. Let them. We'll give them some time. No problem.
Yes, sir. Yeah, they're responding.
Yeah, that's not no problem.
Yeah. Okay, sir.
So here, LoRa simply stands for long range connectivity. Other than the internet, other than using internet data, they are actually hardware elements connected to ranges of more than 200, 300 kilometers without using the internet of things, without using the internet, like your Bluetooth and Zigbee, etc. People should be familiar with Zigbee, then Z waves, etc. Similarly, this also goes out and connects and helps in decongesting the internet. Like, for example, here in Southern Railway, there is a project to connect stations, connect the train and the station using LoRa. And at the station, it connects to the internet via an internet access point, so that the passengers in the trains can know of their exact location, not via internet, but by LoRa networks. So LoRa networks will run parallelly, kind of an intranet between various between train and station, and the station connects to the internet via proper LAN routers. We'll see that also maybe next time. I have content. I have my own experience in all this, and content arranged accordingly. But only thing which is at a premium is the time factor. Then parking. Then IRS simply stands for Incident Response System. That is, I think I referred yesterday, taking the example of Deepthi standing somewhere and seeing an incident and reporting. That's incident response system. The healthcare, nowadays it has plummeted to very dizzy heights due to the COVID syndrome, where only genuine cases of physical examination is entertained by the clinical staff and the doctors. Other cases are done through IoT stack or simply through WhatsApp or through doc apps. I mean, we were also in the process of developing a network, an ecosystem by which all this process is done automated through the cloud without involving any hardware, and the queuing is done automatically, and the patient arrives just in time for the treatment. So yesterday there was a talk about interns and all. You can contact our George sir, the corporate director, to connect with us for such beautiful projects, to have hands-on on that. Okay, that will come up later. Okay, the healthcare, then e-governance. E-governance means participative governance, with the citizens logging in through their personal devices onto the network, and paperless offices. Okay, good enough. Now, what is the IoT? It's the converging the physical and digital world, doing data analytics. Public and the private sectors gets connected and becomes more efficient. There will be a lot of economic benefits and livelihood improves. And what is this thing actually? IoT, it's a network. Of course, a network of not computers alone, but of physical objects, which is normally coined as things. With electronic circuits, there will be software, firmware, sensors, with proper network connectivity. Different types of network connectivities are there. We'll discuss that a little bit later. And what does the network do? It enables these things to get connected to each other and to computer systems also. So things like air conditioners, then pressure transmitters, then pressure gauges, then vehicle tracking, display boards, all form part of the network. So it's basically an Internet of Things, not only computers and computing devices alone. Okay. Now just have a look at this hand-drawn sketch. Just to make things simpler, the cloud is there standing on the top. We have the cloud here, and we have a web user interface, or it is called a web user interface. This is something like, boys and girls, what you saw yesterday in the data center. The data center is this one, the web user interface, and those different layers I showed you. Do you remember, Deepthi? And
Yes, sir.
Vaishnavi, I showed you one picture, no? One topology,
Yes, sir.
where there are
Yes.
different layers. Is it not?
Yes, sir.
So I'm just condensing that layer into one spot. Yeah, very good. So I'm just condensing that layer into one box here, a handwritten box called web user interface. That will be at the data center. So that will be communicating in the cloud. So what does this IoT do, boys and girls? What it does is the various things like automobiles. Yesterday I told you, in a smart city, automobiles are actually nodes in the IoT. Each automobile is a node which communicates with the server. Then process instrumentation devices, then display systems, then MEMS. What are MEMS, Vaishnavi? Electromechanical systems. You know that. I know that all of you know that. Okay, I'm just asking only. Then
Yes, sir.
implants.
Micro electromechanical systems.
Yeah. That's a
Yes.
subject matter of study, for ECE and maybe electrical also.
Yes, sir. We have
Right?
heard.
Yes, sir.
about-
You have an option, an elective on that. No?
Yes, sir. We have an elective.
See, Deepthi, now since you're college, maybe you are in the final year, maybe you are younger batches. Now, since the college has become autonomous, there are a lot of scope to work with the industry.
Okay, sir.
You are not under any chain. You are not under the chain now. The corporate domain, the corporate department or the corporate vertical can take you to the sea heights, can improve your employability by connecting with the industry and feeding them with the engineering students as they need and when they need and how they need. Okay? Am I clear,
Okay.
Deepthi?
Yes,
Yeah.
sir. Yes.
That's an advantage which your younger generation, not generation, younger batches will enjoy. Okay. Now, wearable electronics is like those pedometer and all used for health checkup and all that, and for your warming up and Apple watches and all that. Then household appliances like fridges, ACs, etc., which actually have become smart. You can switch on the AC before you reach home. All those things, you may be having them also. So other than the fancy of switching on the AC before you reach home, there are so many things in the industry, in the smart city, which can make use of that technology. Then the smart technology means making them smart. Like Deepthi and Vaishnavi and others, what I'm saying is smart tech is the embedded module, is the difference between smartness and conventional method. So an electronic circuit, embedded circuit converts them to smart. Can anyone of you give an example of a smart tech device which is available these days to inculcate smartness in objects? Vaishnavi? Deepthi, anybody, can you just take a guess?
Alexa, sir, we have got a response in the chat box.
Alexa is a software, but
Google Home.
that is Google Assist, Alexa, Siri, and all those things now will form the we can create a gateway. Yeah, it's good that you mentioned that. You know, when you ask Alexa where you are, it says it's in the cloud, no? So it is here only. Alexa is here. Alexa, Siri, everybody is there. But unless they identify this system, you cannot communicate now. So what is there, for example, what is lacking, what is required here? If it is not smart, smartness is not built into it.
Sir, we
Can you
got a
see?
response as Arduino.
Yeah, Arduino is one example. Arduino boards can be configured to convert A to D, that is analog, digital, etc. But can you give a simple example? Arduino is a IDE platform. No, it's a platform. It's a single board computer like Raspberry Pi. ICs will be a part of it. It's a good guess. But IC is helpless by itself, no, unless there is a board and there's a circuit and all that. I'm giving you hints, Deepti. You are very near the answer.
Sir, we got a response, Node MCU.
Pardon?
Node MCU.
Yeah. We are similar. Is very near to that.
There is another response also, ESP8266.
Yeah, ESP8266 is a Wi-Fi module. He's very near it. Yeah, Vishnu is very near it. I think we can Deepti award it to him because he's very near it. Like what I meant is a simple word called smart plug, for example. You can convert a fridge to, you can inculcate smartness in a fridge by connecting it to a smart plug. Then use Alexa, configure it with Alexa and Google, etc. So that you can schedule it like in the peak hours, like 6 to 9. You can give an off schedule, a duty cycle to switch off maybe by 6:30, 6:40 and come on again at 8:30. Because the peak load, the current consumption is high. And maybe in the odd hours of the night, you can keep it off. Again, thus save maybe 100 or 200 rupees per 2 months. As per the billing cycle. Yeah, he is very near. The 8266, it's a Wi-Fi board. Okay.
Okay, sir.
Good, yeah, that's good. I'm happy to hear that. So internet communication, so such devices they convert the dumb-headed things to smartness. Like this Wi-Fi smart plug is an example, which of course uses an 8266 or a similar module inside. Okay, right. So that converts it to smartness, and what does smartness do? Smartness makes use of a connection like Wi-Fi, HART is for instrumentation, LAN, GSM, ZigBee, and takes the signal to the cloud. And I'll explain a little bit about the different, we always talk about IoT stack. It is good to know this, to know more about smart cities. There are 5 layers or 5 stacks, 5 layers of stack. Where the bottom layer, we have the devices, then gateway, data, analytics, and application. Application is the data center, where the data center is located. So what does the device layer do? It collects data. And those devices, as I told you, could be anything, machines, MEMS, etc. It will be taken in as an electrical signal. Embedded sensors collect the data. And it may also include actuators. The position of actuation, like the valve opening. Okay, like you see now when you go in some hotels, when you show the hand, the water, the tap opens. So it's a solenoid valve. They are also controlled like that. And then the gateway tab, which I explained now, like the 8266 board, is where data generated by devices processed for delivery to the cloud. Okay, it has to be processed, the gateway. So it could be a non-internet gateway like LoRa, ZigBee, Bluetooth, Z-Wave, etc. Or it may be an intranet, a LAN, before it connects to the internet, as I was telling you just a few minutes back. So the gateway tier, on one side, what does it do? It connects it to a proximity network used by the devices, and the other side will access the network, the main network. It collects and homogenizes the streams into manageable data and deals with the complexity to connect the different devices and their data streams. Just take the example of the smart plug again. Or something more complicated, wherein different protocols are understood by the system and the end result is met by various protocols, a discussion of which is possible but not with the available time. So moving from gateway tier, we'll move to the data layer. There's a data tier or the data layer. Here the data is collected by through the gateways is managed. What is management of data? It's the analytical part. That it prepares itself for analytics. It's a collection center. The hygiene and management and the storage of data is taken care here, considering the 4 V's principle. What are those 4 V's? They are the volume, the variety, velocity, and veracity. Veracity is the authenticity of data. Then the analytical part. There are a lot of jobs on offer in Smart City for data analytics. Electrical, electronics, computer science, etc. And here, my wisdom is generated from the data. Through various analytical techniques, the data is processed, and it may be complex or simple considering the kind of data it is handled. If it has a lot of instrumentation data and electrical data as it is, if transaction is required or not, is a key factor in determining the complexity. And this data so collected can be used for business analytics or for historical storage. Now we are in the application tier, which has 2 parts. One is where the control room is located, where the whole smart city is controlled. All the data, as you saw yesterday in the data center, the various dashboards, collect data, and that's the topmost layer of the IoT. Where what all happens here? Reporting happens, remote monitoring happens, modeling happens, visualization, emulation happens, and mission critical applications run on this, and ERPs run, the smart city projects, maintenance, everything. Dipti, I'm trying my best to make this clear to all disciplines of engineering, since you have told me that you shown me the pie chart. So I'm trying my best, Dipti, okay?
Yes, sir.
So there is
Yes.
always an inclination, because there is always an inclination to go into electronics and computers, but I'm trying my best to make it as general as possible. Okay.
Thank you, sir.
Yeah, welcome. Now coming to the other application of the application tier, that is phase 2. It is for these people working on the data, that is the data center operators, or they are called call center boys and girls. They also need to be monitored whether they are running the control center properly, because that is the hub. That is where the smart city is controlled from. For that, the various KPIs, that is the key performance indices, can be implanted there. Their working can be studied using the same IoT stack. That's how much time they take to take an action. What is the turnaround time? Turnaround time is nothing but from initiation to completion. And various applications from third parties can be run there for this purpose. And they are actually run there to study the working of the system and also the people. Now, from that small figure, which you saw a small while ago, that is, shall we visit back? Just visit back slowly. Yeah, there you are. From here now, with the IoT, things have changed to this. I'm moving it one by one, so as there will be no lag. And here we are, dear students. Here we are, a structure of a smart city communication system. Smart parking, everything from the data center. Okay. See?
Okay, sir.
Yes, sir.
Clear now?
Yes, yes.
Everything is connected. NFC is near field communication. LTE, Then LoRa, Zigbee also, There are other technologies also like WiMAX, Bluetooth, you also, Z-Wave, LTE, long-term evolution, I mean. Then we have the smart meters. Smart meters also have studied. It's not very new technology. But in smart cities now, we are, the one thing I'll tell you about the smart meters are now becoming smarter in smart cities by using PLC technologies. PLC, what comes to mind, Deepthi, when I say PLC? Expansion of PLC. I think instrumentation people know, but electronics also they study optional subject. PLC. For electronics engineers and instrumentation engineers, PLC stands for programmable logic controllers used as actuators for actuating the various processes. But here I'm talking about power line communication. Students, in a smart city, we cannot afford to have smart meters connecting directly to the internet. Why? Because you need a SIM for each house, and there are thousands and hundreds and millions of houses. Just imagine how the cellular data communication will be clustered if we have one home with one smart meter with a GSM this thing or the SIM. Just imagine. I think many of you would have done projects on smart meters now using the GSM module. But we cannot use that in a smart city because it may congest the network. So we have to go for power line communication. Power line communication is nothing but the technology used to send data over the same electrical line. The electrical line here, now you see, these lines will be carrying data also from the house to the nearest substation. Got it?
Yes, sir.
Okay, now, and
Yes,
from
sir.
the power substation, and from the power station, it will be through cellular data. Okay, so
Okay,
number of
sir.
SIMs comes down to
Okay, sir.
substation. And there are only a few substations in one city. Not few means much less compared to only say 1% of the number of houses. Okay, am I clear to you?
Yes, sir.
What I am talking makes sense to all of you, no?
Yes, sir. Yes, sir.
That's all I need.
Yes,
So
yes.
I
Yes, sir. It does.
you see everything here. Smart people means those old folks who are with sensors to know if they fall or not. The smart homes, there is no end to it. If you forgot to switch off the geyser when you're traveling, you can still do it without going back. In the smart waste management, I'll show you one example. So smart grid, I explained it yesterday in smart energy. What would be the source of power? That is, it would be non-conventional or conventional, you still get supply because the IoT stack takes care of inputs from various sources like DG, solar power, wind power, and from the KCB. Okay, right?
Yes,
Yes,
sir.
sir.
Any doubts so far? Or if no doubts,
No,
I'll show
sir.
you the
No,
I'll
sir.
show
No.
the taxonomy. What is the meaning of taxonomy? Taxonomy is nothing but a technical term which simply means the how it is planned, a planning. Okay, how it is spread out, like a functional diagram, something between a functional diagram and a block diagram, and that is what you see on your screen now. Okay, so various communication technologies are listed in which are used in smart cities. Bluetooth, Z-Wave, Zigbee, LoRaWAN, Wi-Fi, WiMAX, LTE augmented, that is take care of GPS also. Then in the taxonomy side, what I mean is the various technologies used, emerging technologies, software defined wireless networking, then network virtualization, which I just talked, visible light communication. I think some of you would have done projects on visible light communication. Okay, instead of Wi-Fi, we have Li-Fi. There are cognitive radio networks, green communication. They are coming up in the near future. Then we have modern communication technologies like Wi-Fi. These are the current ones. These are coming up. Left ones are coming up. Then the various standards. IEEE, all this 802 stands for 802 stands for wireless communication in IEEE. How many of you are IEEE members? Electronics and maybe mechanical also can become, I think. A good number of you are IEEE members, and you can download journals on these things. So this 0.11, 0.12, actually they stand for the various ranges that are available for the various networks. What are the objectives? seamless connectivity, efficiency, speed, and low power consumption. Classes of network, WPN stands for private area network. That is only for the within the house or within the building. Then metropolitan area networks is WMAN, and LAN is your LAN. Then various other networks like ad hoc networks, mode of operations through infrastructure. Ad hoc networks will be for personal area networks. Okay. Now, these are the communication technologies which are used in smart city. What are they? I just told you Wi-Fi, WiMAX, Zigbee, Z-Wave, LoRaWAN, network virtualization, and cellular communication. Let's have a look at them one by one shortly. WiMAX, it actually stands for Worldwide Interoperability for Microwave Access. Can you see that on the screen?
Yes, sir.
Right.
Yes, sir. Yes.
Yeah. Can you see my marking also as I draw with a pen?
Yes, sir.
Very good. So that is what it is. So worldwide interoperability for microwave access. It's a 802.16 IEEE standard. It travels longer distances with high speed. It is a technology for point to multi-point wireless networking. Point to multi-point wireless networking. Then the standard for WiMAX technology is same for the wireless metropolitan area networks. Okay. Now Z-Wave. What is Z-Wave? It's something similar to Zigbee. Low energy radio wave. Developed by Census in Denmark some 20 years back. It is for a Zigbee alternative because of certain problems with Zigbee. Because Zigbee from different brands like Tarank makes Zigbee in one way, somebody else makes it another way. There is some system non-uniformity. So Z-Wave is something superior to Zigbee. Okay, clear now? Are you all feeling happy about such kind of inputs?
Yes,
It will
sir.
help you.
Yes,
It will help you.
Yes, sir.
Please take notes wherever is possible, so that it will help you in your long run. Even those of you who got campus selection and otherwise also can note down, because it will help in their work also. It's good
Sure,
that
sir.
if your employer on your first day, when he talks to you,
Okay,
if he
sir.
finds that you know all these things, Z-Wave and all that, they will feel impressed about you. The first impression is the best impression, especially when you go for a new job.
Sure, sir.
And otherwise also not for impressing, but for your career development also, knowing these technologies is very important.
Yes, sir.
Yeah, right. Now LoRaWAN, WAN stands for wide area networks. It's a low power wide area network using LoRa, long range. It's a part and parcel of the IoT stack used in various cases. And one very familiar case is LoRa parking, which we'll discuss maybe on Saturday. Okay.
Okay, sir.
Now we'll, as I told you, network virtualization is another area of communication for smart cities. NV, it is shortened as. It is referring to the abstracting the network resources which were delivered in hardware into software. Okay. But don't worry about EC. People don't have to worry, because they also need to play a role in embedded development on this. It's not that, see, there is a general feeling that wherever there is no hardware, there is no need of electronics engineers. It's not like that. Please understand, all the industries still need electronics engineers for firmware development and for embedded development, which replaces the hardware. Got it, no, Deepti?
Yes, sir. Yes, sir.
But why do we, I would like to take questions on why are we so allergic towards hardware? Why do we need network virtualization?
Participants, you can answer to the question.
Yeah, please. Simple common sense. Yeah. I'll be dejected if none of you say that. Simple. Very simple, yeah. Think out in a very macro level. Don't go into the depth. This question can be answered by any discipline. Somebody has
Yes,
tweeted.
we have got a response.
What is that? Let me-
Vishnu has said that less cost and e-waste reduction. And
what is that? Cost and?
E-waste reduction.
That is a good answer, but not exactly the right answer.
We have another response also, to do trials and see if it's working, so no time spent or money is wasted.
Yeah, 1/4 of the. 1/4 right. Again. I think it is you are too young to answer that. You need to be in industry for some time. So let me answer it. Simply means that you can sell your product anywhere, or you can have online access and repair it. Simple. Have you heard of OTA? OTA. OTA. Have you heard of OTA? Anybody? For example, if it is a conventional network, there is involves a certain hardware, and you have done the smart city project. Say example Deepthi. Well, let's take example of Deepthi. She has worked. Are you there?
Yes, sir, I'm there.
Just imagine that you are getting a new job and joining, and you are sent to Hyderabad for a project. Okay, right. So you did a project there, completed it, and it started working. Now, then you took leave and came back to Trivandrum, and suddenly there was a problem there. What will you do? If it is hardware based, you may have to rush back and open up the hardware and test it and see what is wrong. But if it's a network virtualization is there, or if it's there, you can take on over the air access. Some hardware also, it's not that you cannot live without hardware. I mean, hardware minimization doesn't mean hardware elimination. Without hardware, no software can run.
Yes.
But discrete hardware has to be avoided. That is specific hardware, which is tailor made. No, in the olden days, no, like Pine Saab also will in those days, no, like when I was working in Bocara Steelman, we had to make custom made electronic circuits with hand soldering, assembling, testing, breadboard testing, and all that. And after you do such a product and send it across to Delhi, something goes wrong. There is no choice. You have to take a train or flight and go there and repair it and see it. But now you can take access over the air, OTA. You know now, even this, you have it of AnyDesk and TeamViewer, etc. No, if somebody's computer fails or some program not working, these Microsoft people take access of your system. Though nobody needs to visit you. Something similar to that. So if Deepthi had done a network virtualization, she could still avoid going there and canceling a leave and work from home and correct it. Got it?
Yes, sir.
Right, that's what it is. That's what I meant. So it will help the network administrators to move virtual machines across different domains without configuring the network again. Okay. Now this is just for completion. I included this. So cellular communication is used. 1G came back in 70s. Then 2G, 3G, 4G, and 5G. Now we are at the door of 5G using CDMA access. And multiple input, multiple output is possible.
Hello.
Somebody is watching something.
There was an interruption. I request all the participants to please mute your mic.
Okay. Now proceeding that this is clear just for the comparison purpose of the various cellular networks. So we just imagine, just understand, only this point you need to note here. From a PSTN is a switching network. Now it has gone to 3G, has gone to packet network, and now we are in the age of internet. Again, virtualization, Deepthi, the sense that now it is internet. That is, you can do anything from anywhere. So everywhere, people are moving towards cloud without minimizing custom built hardware. These are custom built hardware. So what happens is that access is easy, repair is easy, MTBF is better. MTR, that's mean time to repair, also is better. Now e-governance, it is defined as the, we are in the e-governance now. Any doubts on communication? Relate the communications used in
No,
smart
sir.
cities? Anything?
No, sir. It's
No,
very
sir.
clear.
Okay. So what is e-governance? Using digital technologies to frame the relationship between the stakeholder, that is citizens in the case of smart cities, and the administration. So public administration capacity increases and the quality of life of the citizens increases. So we will build the governance on a smart combination of endowments and activities of self-decisive, independent, and aware citizens. In the sense that in smart governance, what happens is that as you are if you are in a smart city, then you are eligible to give a review of the services offered by the city corporation. Like you find that in one road there is a bottleneck because of a parking being allowed in an area, you can communicate with the council by giving video messages or audio, video or picture messages, and using the portal given to you. Every netizen portal will be there, or there will be an app. You can use that and connect to the council, and depending on the majority responses, that parking area is likely to be removed for smoother transit. Just an example I'm giving. Okay. Now, what are the features? Yeah. Now let us look at the jumping. One second. So what are the features of this thing? That is the e-governance. One is the use of information and communication technology that we explained. I did not waste time on this. The computers, internet and telecommunication, digital equipment is made use of. Then better penetration because of the technologies I discussed. Okay. Then geographical information system, just like this mapping for travel and transport, geofencing, areas are coming up, video conferencing, etc. are made use of for smart governance. Then consultation is just what I said. People participation, there will be in smart cities, there will be one day in a month or something where e-consultation can be done. You can consult an officer in the council, the corporation, via video or via portal to improve things. That is a proper channel of interaction between government and citizens. It's possible. Okay. That is, we empower the citizens to voice their opinions, ideas about government programs, schemes, etc. Their feedback should directly reach out to leaders, councillors, city managers, or the local heads. Okay. That's the e-consultation. E-data, that is, data will be available for you. You can pull the data using an app provider or through the portal on the various activities of the government, thus maintaining transparency. Some critical information will definitely be hidden. Okay. So e-governance makes government more accountable and citizen participative in government's functioning. Now this is the evolution. Okay, electronic government, administrative efficiency, interoperability, which I discussed already. So transforms into a smart government. The smart government is the body and governance is the action. Data and evidence-based, that's what evidence-based policy making, not dump policy making. It's collaborative, which I explained. Then improving the quality of result is improving the quality of the life in cities, smart cities. That's it. Now moving on to smart environment. Eco-friendly environment is required. Sustainable environment based on IoT stacks. Reducing current levels of pollution. Achieved by deploying a network of efficient air pollution monitoring devices across the city, which are sensors, and the display board showing the pollution levels. It is continuously monitored using IoT stack to minimize the environmental impact and maximize the efficiency. Now in 24 cities in India, are doing ambient air quality monitoring. Then it encourage public commutes, like use a bus or train instead of your own vehicles, better fuel efficient vehicles, energy saving appliances, environment friendly products. That's all in smart environment. And one example of smart environment I show you pictorially is a garbage truck, and it is not autonomous, but there's a driver. But where it has to go is determined by the smart city network. Like when a garbage bin with active sensors you see on your left side of your screen, when it gets filled up, it sends out a message to the data center. This is what? This is your data center. The data center, then the person there, sometimes, some cases it is automated, some cases it is manned, sends a message to the garage truck which is nearest, garbage truck which is nearest. And the nearest truck reaches there and empties the garbage. Similar is the case with all the manufacturing firms also. So what do they do? The nearest garbage truck means lesser time to clear and saving of fuel. And it doesn't have to smell filthy before it is removed, because automatically sensed by various sensors. This is a good project for all of you. That ends our discussion on efficiency and how efficient the environment has to be for smart city management. Then we go across the smart transportation. This is based out of Holland. The Holland, how it is done is actually my own life experience. So there are 4 or 5 parts: city traffic management, enforcement system, then online traffic data warehousing, adaptive traffic control system. So enforcement system is automatic enforcement of faulters, not like challan and all. It automatically gets enforced and you will get a message on your app, citizen app, as to this much has been fined because of this action. Intelligent transit management system, which includes passenger information system, fleet management, etc. We'll deal it one by one. Mobility management system includes vehicle tracking system and special transport planner. Incident response system, which I have told you the idea behind, and parking management system. I'm going to give you a few life examples on this. And what is it in Amsterdam? I'm just telling you how is the smart city in Amsterdam. It was one of those early cities, although it didn't become number one, but it is an early beginner. There are 12,000 sets of data generated from every district on a periodic basis. And there was an IoT living lab, which I also had visited as an employee of a certain company, as an engineer of a certain company, which is on around 4,000 square meter of land with IoT enabled beacons. What does a beacon do? Beacon is a LED or a laser light, which measures the speed of vehicles passing by and also determines what sort of vehicle. In Amsterdam and in Holland, all the vehicles cannot go everywhere. Through the residential areas, polluting vehicles are not allowed. Heavy vehicles are not allowed. There are certain conditions, and they are all sensed by the smart city topology itself. And the citizens can access the data using Bluetooth devices, and beacons use LoRaWAN machine-to-machine protocol, and up to 3 kilometers in that vicinity. So the smart city will be divided into different zones. Like in Trivandrum also there are 16 corporation zones. Each zone will have its own LoRa network. Then each zone will have its own power generation also using smart grids. And they are even into generation of recycling and getting energy using carbon dioxide to generate electricity. How? Have anybody heard of generating electricity through carbon dioxide? They have started, recently on working on that. From the chimneys of the power stations, the power plants, the thermal power plants, coal-based power plants, with proper treatment processes, which again goes out of scope in this discussion. This will be converted into an electron flow, which means electricity. Flow of electrons means electricity. That's possible. Smart lighting using LED lights, which can be scheduled to start and stop. And there are apps installed in smart lamps in cyclists, which actually glow at you if they feel that you are going to hit them, like collision sensors and all, and that they will glow automatically in night. Now we come to enforcer system, a cloud-based system, to ensure that the traffic rules and regulations are followed. These are the various enforcement systems. We'll stop in 5 minutes and continue on Saturday. I think people are getting tired now. What do you say, Deepti?
Yes, sir. Sure, sir.
Because anyway, it's not going to end today. We may have to take it on Saturday. There are a lot of things like the ma'am also wanted to know more about what we did in transport engineering. Is only coming up. Some real life studies. So red light violation detection in RLVD, then odd and even license plate scheme. That is, we tried to start it here. I think it failed. Odd vehicles on one day, even vehicles another day, and just imagine. And how do you know? How do you know whether it's an odd or even? Is some policeman standing and checking the number plate in Holland and other places? And smart cities, how do you check for odd and even numbers? Any answers?
Anyone?
Yeah. Okay, I'll tell you. It is known as, it's again a
Using computer vision, we got a response.
Computer vision, that is called ANPR, Automatic Number Plate Recognition Systems, using signal processing. You have studied signal processing, no?
Yes.
And
Sir.
DSP. And DSP, we have a module called by layman as what? ANPR, Automatic Number Plate Recognition Systems. Okay. But with that, we can not only see whether it's odd or even, and many other things also. Congestion avoidance systems, then speed violation detection, lane violation, monitoring fleet of hazardous goods, then sensors play a vital role, like cameras, radars, loops, lasers. Loops are actually electromagnetic loops, which just use it this thing. Now speed is equal to distance by time. So in a fixed distance, one electromagnetic loop is created, and the impingement at the start and the end is measured, time difference is known, then the speed can be calculated because distance is known. Then data collector is processed. Then from that, we'll take the speed and length of the vehicle. Length of the vehicle, why? Any answers? Length of the vehicle? Because as I told you, in Sweden, in Holland, all types of vehicles are not allowed on all roads. There are limitations depending upon the length of the vehicle, the height of the vehicle, etc. So no violations are allowed there, and nobody is waiting at the road to see that. Everything is automated. The information process will be stored in a database. It can be accessed from the cloud or from an intranet system. So overview of system, detecting the traffic violations, overspeeding, red light, etc. Road usage patterns there in Holland, we have developed systems which incentivizes, means gives in form of lower taxes, etc. to people who follow the rule. Positive behavior among road users are not encouraged just by a pat on the back, but by incentives, the form of lesser taxes, other concessions, etc. so that people get motivated. Then these are all the things which are seen on the screen now. As already told to you, there are 3 types of enforcement applications. One is violation, signal violation. Other is don't use a road not meant for you, not meant for your vehicle. Then some hazardous substances movement. If you are moving with hazardous substances, you are allowed to move only through certain roads. That is also checked. So just imagine, boys and girls, the data center, how beautiful it will be in Amsterdam. No, I am not allowed. I have pictures. I am not allowed to share them. Maybe after getting permissions, sometime later, I may be sharing such beautiful pictures of live pictures of the event, of the scene. Looks so great, It's the brain of a human system. This I'll just skip because it's a trajectory. I'll just explain with this picture. This is how, what I told you, no? These two are the truth star means devices to check that. I told you the loop creation for A. From this, we get the length of the vehicle. Length can be seen. The speed can be seen. And driver behavior not here in another system. This is a trajectory control. Then city traffic management, transportation part. This dynamic bus platform system is used like in our main central station. The buses get the Russian and they are fighting for the available platform. Here on the dynamic display system on the bus, as it reaches within 1 kilometer of the bus station, the platform allotted will be displayed and will be guided electronically to that platform, the bus. So there is no congestion. And this data warehousing, just like we have money, we have banks for storing money, we have their banks or data centers for storing traffic data also for 10 years. It can be used to let you go if it's your first instant and punish you mildly if second instant, like that, and jail you if it is a fifth or sixth instance. Emission zones, dynamic parking guidance system. As I told you, this is for parking the vehicles which are used by commuters to get the bus. So there is no habit of going end to end by your own private vehicle. They take the car or bike only to the nearest bus station. From there, they catch a bus. I think we discussed this yesterday. Then this incident response system, as I told you, what it is, it's clear to you. Those who were yesterday are also has known what it is. Just a method to know what happened, where, what time. Okay. Then this is a traffic control center. This building, so pictorially I'm showing this is a traffic control center building. So such kind of investment, see participants, students, such a big center. It's actually a pictorial of the actual thing because the original photos cannot be shared. That is the structure. It's a multi-storied building. One of the top skyscraper buildings in the city is just for regarding traffic. So what is the end result? Less number of accidents, less commuting time, safety, peace of mind, and increased productivity. This vehicle tracking and tracing supposed to be covered today, but I'll cover it tomorrow, next day. Dynamic routing means you will be routed to, see, for example, you are going from say Kovalam to say Karakutam, you'll be routed through the nearest part. And with this, I'll stop. With this picture, I'll stop. This is the VMS means variable message system. These messages are controlled from the data center to show the amount of traffic up ahead so that they can take deviations, or they will be forced to deviate as per the traffic conditions. NTW is National Data Warehouse of Dutch. National Data Warehouse, different types of sensors. So the road is fully wired, as you see here. So actually the graphical of the actual things. Okay. The traffic control center is a data center, is housed here, and the bank is here. The data bank is here. Okay. Now, I think we'll put a stop here for the time being because all of you would be tired, no? It's already 7-ish, I think. Let me see.
Yes,
So
sir.
I think we should put a stop here because the data flowing from me or the info flowing from me is endless because I'm so happy to tell you all this from my life, from my experience. And I spend a lot of time preparing these slides so that I'll be able to communicate properly. If I don't need this presentation to talk to you, but a visual aid is better than just talking on thin air. That's why I was prepared. A few of the slides were shown or data was shared in the last session on IoT. I've taken it from there, but this is on a different platform. So that's it from me for today. I'm sorry that I could not complete everything in 1 hour, but there are a lot of things to show you, like case study of vehicle tracking system with circuits and all that. Just a second, I'll run through that if you allow me, just 1 minute.
Sure, sir. Sure, sir.
I just run through that. I just see if I can run through that. This is actually, these are the actual vehicle tracking devices with circuits explained. Circuits are also explained. Like the actual card is shown, because these were, some of them were done in our country, so I have the freedom to show them. All these will come up in the next session. Okay, so that's it from me. Thanks for listening. Hope you enjoyed my session. Thank you. Over to you, Deepthi and Vaishnavi.
Okay,
Thank
sir.
you, sir.
Dr. Pine, please talk and tell us a few words about this event, about this evening. Sir,
Fine, sir. Can you hear me? Hear us?
Yes. Okay. Fantastic.
Yeah.
Very.
They are asking for your feedback.
Yeah, it is very nice lecture, and for me everything new. So whatever I gain, it is good for me. When something come on IoT email, I get confused always. I am
Yeah.
mechanical person
Yeah, right.
basically, so you understand the problem.
Okay.
Yeah.
Yeah. The boys and girls, you are now we are with Dr. Pine, who is having so many years of experience in mechanical engineering, especially in vibration testing. You can just feel a vibration and tell you whether it is malignant or benign. He has lots of years of experience in India and abroad in vibration testing. He has a knowledge center in Mumbai where he holds classes and lectures on vibration monitoring, etc. And he's a moving encyclopedia on vibration measurements and conditional monitoring, which is again an interdisciplinary subject. Even electronics engineers and instrumentation engineers and even computer science engineers need to know that. Okay, and he works hand in hand with me regarding censoring of the condition monitoring sensors. Again, IoT comes into play there. You can't imagine a place or a node or a location or a device without IoT in a smart city. That is the statement from me in this evening. That's what. Pine sir, anything else to say?
Yeah. Actually, this is a new area. Whether it is electrical, electronics, instrumentation, electrical, whatever. You need to have an asset management effort. And for that asset management, ultimate aim of the machine is to have a reliable machine, whether it is software reliability, whether it is assets, some hardware reliability, or any other assets mechanical. So we need to have a different branch exposure, and reliability engineering is a multidisciplinary area, interdisciplinary in fact, and condition monitoring is also related to this, only to diagnose the machine fault oiling time. So different type of condition monitoring tools are available. I am associated in my own, I have started in my own Center for Reliability and Diagnostics here in Mumbai, where you are providing services as well as testing. I am associated since long with TNC, and I recently last semester we have taken reliability engineering full course of University of Mumbai. Myself, I have taken,
That's right.
including examination everything. Now I am taking project management course also of
Exactly.
University of Mumbai. Um,
That's good, sir.
and you are always welcome. Reliability or condition monitoring, any topic you like to have, or IT, computer science, electronics together. You can have a session for that.
I think
Good plan structure for the session.
yeah, mechanical engineers will directly benefit and others will benefit indirectly, of course. Right.
Yeah, now my branch has become no more mechanical branch. It has become a mixed branch for me, and
That's right.
predictive maintenance or predictive
Yeah.
IoT and ML very much important for assets,
Yeah.
whether it is your hardware, software, anything. So this is a
That's right.
predictive analytics also involved. Only thing sensor from remote location for the ultimate prediction of the equipment health. Okay, so how to
That's
use
right.
the sensor of IoT sensor and all.
That's right. That's right.
Okay.
Right. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir. George, sir, a few words from you, please.
Yeah, today is the second day. Now I think all the participants might have got an idea about the kind of projects they will be working in when they get a job. And it's not like, studying and working in projects that makes a lot of difference. In the college, you will get only the basic concepts, but you have to expand it by applying in practical case studies like this. Anyway, we'll be continuing on Saturday as well.
Sure.
We will get more insight into the further aspects of smart city.
That's right. I'm happy, sir. I'm happy, sir, that the students are actually participating, and there is a good interactive session. I enjoyed it, and hopefully through our corporate department, headed by you as a director, we can connect in the future also with various projects, live projects, and they'll be happy to have contributed to the making of the Indian industry.
These 60, 70 students, they are the really interested students in, from second year and third year. We haven't done this to the first years. Of course, first years, there will be a lot of interest in this, but they will not understand much about the technology.
That's right.
So
that's right.
These 60 students definitely we can connect with, and they will be interested in, taking up projects related to smart cities and associated, projects.
Thank you, sir. So, good evening, everyone. When the second day wraps, we are leaving the session with a lot of new information, which are explained as simple as possible. Thank you, sir, for ensuring us that opportunities are not over yet and providing us with more project ideas.
Sure.
Personally, for me, our final year project is based on smart base management. Actually, this talk gave us confidence to do it and got a better vision about it. Thank you, sir, for sparing your valuable time for us. Thank you,
Sure.
Dr. Pine, for being us with this evening. Next, I would like to thank Dr. T.M. George, sir, for giving such an amazing opportunity. Thank you, faculties, for being here with us, and thank you for your support. Last but not the least, thank you, my dear friends, for sparing your time and being here with us to be a part of this wonderful session. The feedback form will be posted in this chat. Please fill the form before leaving the session.
Oh, Vaishnavi, we are posting in the Zoom network itself, or?
Yes, sir.
So
now I'd be posting.
So okay. So we need to continue, no?
Yes, sir.
Okay.
Sir,
Yesterday, but
actually, it's okay, sir. We'll share it in the chat WhatsApp group.
yeah, that'll be better,
If you
no?
have
Because
any emergency, you can leave, sir.
I have a meeting coming up. It's okay if it is required. I can stay. Otherwise,
No, sir. That's totally fine. We'll share it in the WhatsApp group.
okay, sir. Okay, George, sir. So that's it for today.
Okay, then. Thank you.
Thank you so much for giving an opportunity again. Love to be a part of the Mar Basilius community. Thank you.
Thank you,
Thank you so
sir.
much. Bye.
Thank you.